Welcome to Tenor Tech, where I solve the problems you didn't even know you had.
You start by validating hardware and picking a model. This directs every next choice. Check GPU RAM, disk space, and install Python 3. 10 plus with Conda or Venv. Once done, add CUDA drivers for NVIDIA or prepare CPU runtime if no GPU is available. Next, decide on model size and precision. 4-bit or 8-bit quantized models save memory. FP16 gives higher fidelity. Finally, prepare storage layout and a virtual environment so installations stay isolated and reproducible. Once weights and tokenizer are in place, convert or quantize them for your target runtime to reduce memory use and increase throughput. Use established tools to produce 4-bit or 8-bit artifacts. This reduces RAM needs while keeping latency low. Then load the model with your chosen runtime, transformers for Python, Llama, CPP for C or ONCs for cross-platform deployment, and tune threads and batch size. Make sure to test with short prompts and measure memory, latency, and token throughput before moving to serving. Now launch your service. Start a local API or REPL and restrict access to localhost unless you add authentication. You should run a few canonical prompts to validate output quality and measure latency. Make sure to monitor GPU, CPU, memory, and swap usage. Logs will show leaking or OOM patterns. Persist configuration and model checkpoints so you can roll back. If something breaks, check quantization mismatches first, rerun conversion at different precision, and reduce batch size or enable.
Thanks for watching. Subscribe to keep your life in tune.